What's the probability for a single spin in the following situations? You guys got the numbers 1 through 8 listed on the spinner, and then you got the colors. You got 2 red, 2 white, 2 purple, 2 yellow. All right. So what is the probability for a single spin? Probably you get a red or an odd number. Okay, so or is add. Just remember that if we're going to go directly, math, how to do this. Probability of getting a red, make a fraction out of it. So it's going to be this plus this. Okay. So what's the probability of getting a red? Anybody? 2 out of 8? This is kind of like 8th grade math, actually. There's 2 red. You see it unless you're colorblind. 2 out of 8. Odd. Half is even, half is odd. 4 out of 8? Yes or no? Okay. So now, I said a double count. If there's a double count that is both red and odd, you got to subtract. Is there a red and an odd? No, there's no. So 0 out of 8, there's nothing there. The answer is 6 out of 8, 3 out of 4. 75%. That's it. So we're going to do the second one just the same. Or is a plus. So we're going to make fraction plus a fraction. And we'll deal with if there's a double count in a minute. Probability of yellow. Say it. What's the probability of yellow? 2 out of 8. Okay. Probability of prime. Okay. Let me review this prime thing for people. Is 1 a prime number? Yes or no? And the answer is no. Because it has to be itself and then multiplied by 1 only. So 1 times 1, there has to only be 1, 1. And there's 2 of them, not a prime. So the first prime number is an even number. 2 times 1 is 2, and then 3 times 1 also. 4 is a composite, because it's going to be 4 times 1, 2 times 2, composite. All right, enough. So 1 is not, 2, yes, 3, yes, 4, no, 5, yes, 6, no, 7, yes, 8, no. So 4 out of 8. Now, here's the question again. Is there a double count? Is there a yellow that is also prime? Is there a yellow that is also prime? And the answer is yes. Which one is it? 2. Correct. So we're going to go minus 1/8. So the answer is going to be what? 5 over 8. And whatever that decimal is, or percentage, change it to a percent. If you need to on the test. 5 out of 8. I'm gonna move on. If you need to copy anything, you can always go to the website. All right, moving on. So, lesson for today is conditional probability. Conditional probability contains a condition that may limit the sample space for an event. All right. Probability of event B given event A. Here's the formula. P of B given A is equal to P of A and B happening over P of A. Am I really going to do this again? Then I wish you just keep the other video. Unless I think of a better example. So, you guys are copying it down. I don't know why though, but it makes, I think, when you make it very personal, that's when it makes the most sense. So here's the situation. It's for, like, let's say this particular girl. And see, the thing about it is that people tend to overthink it and then just say, why couldn't it be like this? Just listen to the story and then make it very traditional. So, or here's what I'm saying. So this girl, no, there's this girl, and she wants to get a boyfriend. Please don't ask me anything else. Just listen, and this is what's happening. So this girl wants to get a boyfriend. So probability, she wants to get a boyfriend, whatever, just somebody, and significant other, a boyfriend. Okay, boyfriend. Okay, all right. But she wants to limit the sample space. Very picky. Given that, better be at least 6 foot tall or taller. You gotta be 6 foot tall. Very tall, 6 foot tall guy. Person. I don't know. You're limiting. This second part is the limiting part. You see? So boyfriend, I can't even spell. Is this how you spell boyfriend? So yeah, this is weird. That's kind of the idea, that the second part is limiting. Maybe I should. That's enough. Just telling you that the second part is that limits the sample space. All right. But anyways, so what I was talking, I was going to talk more about it, but it's just understand that the second one, it limits the sample space. In addition, I used to do this poll in the classroom, in every single class, and go, hey, who lives in a house that has a garage and a swimming pool? And then I tried to do it in my first period, and then it was like 0 people that lived, or they just didn't want to participate. And then I asked the one where, hey, how many people live in a house that has a swimming pool but no garage? And it was 0 again. So anyways, I'm not even going to do it in this class. Let's just say that I was able to record the data for some class in a prior year. Okay, in this particular class, student in that particular class that lived in a house that had a swimming pool and a garage, there were 5 of the students in that particular class. Okay. Go right now?
Right now, library. Thank you.
Garage, no swimming pool. So most people probably live in a house that has a garage, no swimming pool. In that particular class, there were 20 of them. No garage and a swimming pool. That's a little bit of a weird house, no? No garage, but it does have a swimming pool. There was 1 in that particular class. You gotta go to the library and just take that test. No garage, no swimming pool. 8. And now we can fill out the rest of this. People that lived in a house that had a garage. How many people lived in that particular class that lived in a house that had a garage? Huh? Total number of people that lived in a house that had a garage? 25. Add straight. 25. No garage. 9. That had a swimming pool. that had a swimming pool? 6. No swimming pool? 28. And how many total students were there? And let's say they all were participants. 34. Now we're going to do the actual. And this is what I say to people, and it's every year. It's like either you get it or you don't. You know, and then it's going to take a long, whatever. Either you're going to get what I'm going to give you the conditional here. What is the probability? What was the probability in that particular class of me picking a student that lived in a house that had no swimming pool, that lived in a house that had no swimming pool, given that it is one of the houses that had a garage? Who thinks they got it? See, I'm just going to be either you get it or you don't. Like, here we go. Here's for that this data here, for the data presented. What's the probability of picking a student that lived in a house that had no swimming pool, given that it is out of the houses that had a garage? Raise your hand if you know the answer. What? 20 out of 25. All right. Let me see if it's correct. Let me go. Okay. So the limiting sample is, or even in another way of looking at it, imagine that this is, I'm going to switch it to another story. Let me switch it to another story. Because maybe what I just said is still so like, don't make sense. Let me make it even more personal to you. Eventually you will, I hope that you try to get a house, your own, buy it, become a homeowner, and you get a realtor, and you tell the realtor, and you say, I want to get a house. And the realtor says, what do you want? What do you want in the house? So you say this to the realtor. I want a house that has no swimming pool. No swimming pool, because they take too much to take care of. Too much money. No swimming pool, but it better be out of all the houses that have a garage. I need a house that has a garage because I have a car that I need to take care of. So it's out of all the houses that have a garage, it better be one that has no swimming pool. All right, let me go ahead and do it. So now I go and I look at my data here, and I go to all the houses. I'm going to look at all the houses that have a garage. $25 out of all the houses that have a garage. Swimming pool and no swimming pool. No swimming pool and a garage. No swimming pool. No swimming pool that has a garage. Garage, 20 out of 25 is correct. That's it. Either you got it, what I just did, or you don't. Let me do one example, one more. Let me come up with one right now. Let me come up with one. See if you can get this one. Probability of getting a house that has a swimming pool, SP for swimming pool, and a garage. No. Yeah, let's go with garage, no? No, you know what? Let me switch it up. Weird. No garage? I don't know. No garage? Given that it's one of the houses that has a swimming pool. Let me switch it up like that. It changes. It depends on how you write it down. The answer will change. So what I'm saying here, here's what somebody says. So the realtor goes, what do you want? And the person says this. I want a house that has a swimming pool. That has a swimming pool, but has no garage. Man, you're a weirdo. I'll look for one. How can you want no garage and you want a swimming pool? Okay. All right. So who got the answer? Off of that data. What is it over there? What? 1 over 6. All right. So now let me see if what you did. Let me see if look. So the realtor goes, okay. Well, it's going to be very few of those houses, but I'll look for one for you. Swimming pool. How many total houses have a swimming pool? Total houses that have a swimming pool. 6 candidates at the bottom. That is correct. Swimming pool and no garage. Swimming pool and no garage. 1 out of 6. Hey, I found one house. Either you can like it or not, because you only got one choice. That's it. Let's go. Let's continue on. That's the idea again. Well, let's do one more. Let's go to that data from a while back. We did this one. I don't know if you were here already. You already copied this down. You could go to that, flip to that page where you copied this down a couple of days ago, so you don't have to write it down again. We did this a couple of days ago. Do you remember? Yes. It was from the Titanic, wasn't it? We're telling somebody was saying it was from a airplane or something, I know. But it's a crash. So here's the question again. Looking at this chart or whatever, table. Here we go. Here's the question again. This line going up and down it's called given. Given. So for all the data of the people that died in Titanic, what's the probability of picking a survivor, given that it is out of all the third-class passengers? What's the probability of picking a survivor, given that it is one of the persons that was in third class? That's what it says. Probability of picking a survivor, given that that survivor is one of the people that were in third class. That pretty much gives it away. Annalise, what do you think it is? Probability of picking a survivor, given that he's one of the people that was in third class. Out of that information there. What number goes on top? I don't know. What number you think goes on top or at the bottom? Give me numbers.
The bottom would be 7 or 9, and then the top would be
180 what?
1.
Okay. So let's see. Let me go over this. Let's see if those numbers are correct. I want to pick a survivor, but out of that survivor better be a person that was in third class. Total third class. Total people that were in third class. Third class, total people that were in third class is 709. That goes at the bottom. That is correct. Survived in third class also. Third class survivor is 181. That is correct. It's not, yeah, that's easy. It's not that hard. Either you get it or you don't. Like, there. Let's do one more. Let me come up with one more. Probability of what? Second class? SC for second class? Given that not survived. All right, so probability second class. Given that it's one of the people that did not survive. Who thinks they got it? What is it? 166? Out of what? 384? 284? So the approach, this is my approach. Then it's just too easy when I approach it like this. Second class, given that, okay, this is out of total this. Total not survived, total not survived, total not survived, not survived. Total not survived, 817. And then not survive, second class, not survive. Second class, not survive, 166. That's it. That's all there's to this. We're done.